Hi friends, welcome to Unacademy. Hi friends, welcome to Unacademy, India's largest learning and teaching platform. Hi Nalinakshi, welcome to the class. As you all know, Unacademy offers plus courses for Karnataka CET students. Students who will be writing CET exam in the year 2021 can subscribe the plus courses. Okay, so students can subscribe the plus courses. Whenever you subscribe the plus courses, kindly make use of the code BHAVANILIVE. Now what is a plus course? A plus course means structured live courses. When I say structured live courses, students, it is both class 11 and class 12 topics will be done in detail. There will be also live doubt clearing sessions. At regular intervals, quizzes will be conducted, and it is for your self-analysis, students. You can clarify your doubts. Okay, you can strengthen your concept. You can find out through the quizzes whether you have studied the topic enough, or is it little more study is required. You are also given daily practice paper, full length mock tests, and also for a single subscription you have unlimited access. Students, there are 3 different plans we have. We have 12 months plan at the rate of 12,375. We also have a 6-month plan at the rate of 10,125, and we have a 1-month plan at the rate of 2,250. So this is for the new subscribers. We have a trial offer that is for 1 month at the rate of 2,250. So students, kindly inform your friends, brothers, sisters, neighbors, relatives, your own classmates, your juniors about the plus courses, and ask them to subscribe the plus courses. And whenever they join, ask them to make use of this code BHAVANILIVE. You are going to make use of the code BHAVANILIVE and subscribe the plus courses. As you all know, we are trying to finish, because in the last class also we had conducted test on Amines. So we are going to continue that part, Amines. That is why I have written Amines 2. Students, remember, if you are liking my class, I hope you have watched all my sessions, previous session, and if you are liking my class, kindly press the bell icon for further notification, so that you will come to know about my classes, and also press the like button, like, share and subscribe these classes. Kindly share these videos among your friends. Okay, so today we are going to study once again Amines. Okay, 2-3 mock tests I will conduct. See to it that a lot of questions we cover in these sessions. So without wasting our time, let us go to question number 1. Students, you can see question number 1 on your screen. The correct increasing order of basic strength for the following compounds is. You have here aniline. Okay. You can see for aniline the group attached now is NO2, and you have aniline, and the group linked is methyl group. So among the 3, you have to keep them in the lowest basic, least basic, and then in the increasing order. So students, if you have some answer, you can write it in the comment box. Okay. Meanwhile, let us see students. All of them are bases because you know the nitrogen has a lone pair. There is a lone pair. Okay. Now look here. In case of, the third one, you have methyl groups attached. Methyl group is attached. Whereas here you see NO2 group is attached. So now what is the difference when methyl group is attached and NO2 group is attached? We know that methyl group exert plus I effect. Okay, these are electron releasing group. The electron releasing group release electron towards resonance. What is a base, student? A base is a substance which can donate a pair of electron. Suppose if it can donate the lone pair easily, then it is a strong base. Now here nitrogen has a lone pair. Okay. Lone pair is present, which is actually involved in resonance. We all know this lone pair is involved in resonance, isn't it? But there is a group which is methyl group. It is an electron releasing group. So electron releasing group increases the electron density on benzene ring. As a result, in this case, the lone pair can be donated easily. So this one, if I take this as third one, this is strongly basic. If you look at this case, there is a powerful electron withdrawing group. It exerts minus I and minus N. Powerful electron withdrawing group is present. It withdraws electron from the resonance. That means this lone pair will be, participates in resonance. Therefore, the donation of this electron pair or the lone pair becomes difficult because you have a group here, student. Look here, you have a group which is withdrawing electron, student, from the resonance. That means the donation of this electron becomes difficult because here the electron density is less. Therefore, the lone pair will be distributed here. So the donation becomes difficult. This will be least basic. Whereas in this you do not have electron withdrawing group, neither you have electron donating group. Therefore the order will be actually, what will be the order, student? The least basic is the second one, and then you have the first one, and then you have the third one. Always remember, students, electron releasing group always increases the basicity. Electron withdrawing group always decreases the basicity. Therefore, answer will be option C. Okay, we'll go to question 2. Which of the following reaction is appropriate for converting acetamide to methanamine? Now, how do we convert acetamide to methanamine? Among the 4 reactions, which one is a conversion of acetamide to methanamine? Very clearly you can see here in the name itself, amide. Hofmann bromamide reaction is a conversion of amide to amine. Answer should be option A. From the name itself, it's very clear, student. If I take acetamide, CH3CONH2, and bromine, and potassium hydroxide, you know that methyl group migrates here, and you are going to get CH3NH2. That is nothing but methanamine, isn't it? Other than that, KBr is formed, K2CO3 is formed, and water is formed. So acetamide or ethanamide is converted to methanamine by Hofmann bromamide reaction. Stephan reaction is conversion of alkane nitrile to aldehyde. So this is not amine preparation. Gabriel thalamide synthesis. In Gabriel thalamide synthesis, as the name suggests, thalamide is taken, imide is taken. Correct, students? Imide is taken. Carbyl amine reaction. It is a reaction shown by amines, primary amines, and it is not the preparation method of amines. So only possibility is option A. So we'll go to question number 3. Which one of the following nitro compounds does not react with nitrous acid? So you are given option A, CH3, CH2, CH2, NO2. You can see here CH3, CH, CH3, CH2, NO2. Okay, you have C here 3CH3 and NO2. Similarly CH3CO, CH, CH3, NO2. There are 4 options given. The question is now which one does not react with nitrous acid? Now which one does not react with nitrous acid, student? Which one? What do you think the right answer will be? Now this is nitro group NO2. Here also you can see NO2 group here, and here you see NO2, and here you see NO2. Now this is alpha carbon. Alpha carbon has 2 hydrogen. So this compound is reacting with nitrous acid. Okay. Now here you see carbon. This is alpha carbon. Alpha carbon has hydrogen. That means it reacts with nitrous acid. Now take this case. This is nitro group. This is alpha carbon. You can see here alpha carbon. And the alpha carbon does not contain alpha hydrogen. So no alpha hydrogen cannot react with the nitrous acid, or in other words tertiary nitroalkanes. This is a case of tertiary nitroalkane. Does not react with nitrous acid because it does not possess alpha hydrogen. Answer is option C, student. Here also you will see that there is H present, alpha hydrogen is there. That means answers or react with nitrous acid. So we'll go to question number 4. A given nitrogen containing aromatic compound A react with tin in HCl followed by nitrous acid to give unstable compound. So you can see very clearly nitrogen containing aromatic compound A. So with that hint nothing can be done because all are nitrogen containing and they are aromatic in nature. React with tin in HCl. So this reaction we can recall. Followed by reaction with nitrous acid, give a unstable compound. Okay. This on treatment with phenol, a beautiful colored compound is formed. Okay. The molecular formula of the compound is also given. The structure of compound A is. So you have to identify A. So come on students, do you have some answer? Do you have any answer? Is it aniline? Is it nitrobenzene? Is it phenyl cyanide, or is it benzamide? So which is the right answer? Now see, you have studied this reduction reaction. And if you remember well, student, you have studied this in preparation of aniline, that is nitrobenzene is reduced with tin in HCl. So what do you get? You get aniline, isn't it? Nitrobenzene is reduced to aniline. Nascent hydrogen is formed. Okay, it will give you nascent hydrogen and that will give aniline. Now aniline is made to react with nitrous acid. Okay. You know the reaction, whenever aniline react with nitrous acid, diazotization reaction occurs and you get benzene diazonium chloride. This is an unstable compound. So you get benzene diazonium chloride. So you are going to get benzene diazonium chloride, diazotization reaction. Now this benzene diazonium chloride, okay, react with phenol. You know the para attack, and you know you will get a dye. A dye is formed. Okay, you are going to get a dye of this type. This is para-hydroxyazobenzene. A dye is formed. A dye. Okay, colored dye is formed. This is a dye. Para-hydroxyazobenzene. You can see here the carbon number is 12 in this case. You can see this is C12. And you can see H is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So it is H10, N2 and O. That means answer should be option B, isn't it? Option B will be the right answer. Okay, we'll go to question number 5, students. The correct statement regarding the basicity of aryl amine is. So we have to pick the correct statement. Which is the correct statement for basicity of aryl amines? Aryl amines are generally more basic than alkyl amine because of aryl group. Is it true, students? Is it true? If you take aryl amine, for example, if you take aniline, and if you take alkyl amine. In case of alkyl amine, in both these cases, students, there is lone pair, but here nitrogen is attached to plus psi group, which will increase the electron availability on nitrogen. So basicity increases because these are electron releasing group. As they release electrons, the electron availability on nitrogen is more, so that can be given easily. So more the alkyl group, it is stronger is the base. In this case, in aryl amine, the lone pair is involved in resonance. We know that the lone pair, okay, the lone pair of electron is involved in resonance. So it is not readily available for donation, isn't it? Not available for donation. Therefore, aryl amines are always less basic than, alkyl amine. So this cannot be no. Aryl amines are more basic, no. Aryl amines are less basic than alkyl amine because the nitrogen lone pair electron are delocalized. Delocalized means they are resonance stabilized or involved in resonance by interaction with the aromatic ring pi electron system. This is a correct option. That's what we said. The lone pair interacts with the pi electron and there is a delocalization of electron. When this electron is delocalized, what do we mean, student, when I say delocalized? What does it mean? It means that the electrons are spreaded, distributed, isn't it? So they are not available for giving. They are not readily available for donation. So this is weak base. Option C is the right answer. Last option, let us just check. Aryl amines are generally more basic than alkyl amine. No, this cannot be. It is less basic. So option C is the right answer. Question number 6. The product formed by the reaction of aldehyde with primary amine is. Students, anyone has the answer? Anyone wants to give the answer? You can give your answer, student. Aldehyde with primary amine. Aldehyde with primary amine. What is primary amine? RNH2. You know, this water is removed and you are going to get RCH double bond NR. So this is N substituted. Correct, student? N substituted. See, if I write like this, instead of R, if I write hydrogen, it is imine. Imine, isn't it? Imine. So this hydrogen is now substituted. Therefore, N substituted imine is formed. Now, N substituted imines are also known as Schiff's bases. Therefore, answer is option C. Go to question number 7. The following reaction. Now you can see, student, aniline is given, benzoyl chloride is given, and you can see in the reaction, see very clearly what exactly is happening in the reaction. Just see. Hydrogen of aniline, see this is aniline, hydrogen of aniline is substituted by this group. What is this group? Let me write it. This is C6H5CO group. Correct? H and Cl will be removed, students. Therefore, this hydrogen is now replaced by C6H5CO group. That means benzoyl group. Hydrogen is replaced by benzoyl group. Benzoyl group. So it is called benzylation reaction. Replacing hydrogen by an benzoyl group is benzylation, and it is nothing but Schotten-Baumann benzylation reaction. Schotten-Baumann benzylation reaction. If you want, I will add the word here itself. Okay, Schotten-Baumann reaction is nothing but Schotten-Baumann benzylation. So in acetylation, you know what happens. It is acetyl group. Hydrogen is replaced by acetyl group. Friedel-Crafts means hydrogen will be replaced by methyl group, or hydrogen will be replaced by which group? Acetyl group. So that is Friedel-Crafts reaction. What is Perkin reaction? Perkin reaction is totally a different reaction. It's a reaction of aromatic aldehydes that will react with acetic anhydride and form alpha beta unsaturated acid. This is Perkin reaction. So replacing or substituting hydrogen by an benzoyl group is called Schotten-Baumann benzylation. Answer is option C. Okay, we'll go to question number 8. Method by which aniline cannot be prepared is. So what are the method by which we cannot prepare aniline, students? Degradation of benzamide with bromine in alkaline solution. Okay, option A. Option B is reduction of nitrobenzene with hydrogen in the presence of palladium. Okay, hydrogen in ethanol. Okay. Potassium salt of phthalimide treated with chlorobenzene followed by hydrolysis with aqueous NaOH solution. Option D, hydrolysis of phenyl isocyanide with acidic solution. Students, in which of the method you cannot prepare aniline? Which method, students, you cannot prepare aniline? Anyone has the answer? You can write it in the comment box. Anyone? Okay, students, do you have the answer? Now look here. Degradation of benzamide to bromine. Benzamide with the bromine. This is nothing but Hofmann bromamide degradation reaction, and we know that in Hofmann bromamide degradation, amines are formed. If I take benzamide, I told you how to predict the product directly. If it is student Hofmann degradation reaction, how do you directly predict? You have to simply remove the CO and remaining is the product, that is nothing but aniline. So aniline is prepared. When nitrobenzene is reduced, student, when nitrobenzene is reduced, we know that the product formed is aniline. So this cannot be. Potassium phthalimide. So we will take potassium phthalimide. Potassium phthalimide. Okay. And chlorobenzene. If you take potassium phthalimide and maybe chloromethane, for example, you will get methylamine, isn't it, as the product. But here the question is now not chloromethane, chlorobenzene. So I am going to take C6H5Cl, student. So I will be taking chlorobenzene. Now look here. We are going to take C6H5Cl. Students, as you all know, this is nucleophilic substitution reaction, isn't it? And aryl halide does not undergo, this is aryl halide, does not undergo nucleophilic substitution under ordinary mild condition. Reasons are many. If you want one of the reason, I will give you. Here you have a lone pair. The lone pair is given. That means the bond between, this is negative charge, the bond between chlorine and this one, this is partial double bond. Can you see, student? It is a double bond and it is very difficult to break this double bond. You cannot break the double bond, isn't it? So if you cannot break the double bond, you cannot expect that nucleophilic substitution reaction. Okay, and not only that, the carbon here is sp2 hybridized, highly electronegative. Look, student, this carbon is sp2 hybridized, highly electronegative, student. Therefore, the bond which is between CCl is stronger and shorter and stronger, difficult to break it. So there are many reasons by which aryl halides are not easily undergo nucleophilic substitution. Therefore, this cannot give you aniline. So answer is option C. We will see one more possibility, hydrolysis of phenyl isocyanide in acidic condition. Let us see whether is it possible. Let me take phenyl isocyanide, N triple bond C. Correct, student? Okay, so we are speaking about acidic hydrolysis. Acidic hydrolysis. So what will happen? C6H5, you are going to get NH and you will be having C double bond OH, isn't it? Okay. So this is what you get, and further again it undergo hydrolysis. This you will get, and here OH will be added. That means you are getting C6H5NH2, and also you are going to get formic acid, isn't it? HCOOH. So aniline is formed in the reaction. That means even hydrolysis of phenyl isocyanide. Isocyanide means NC, also will give you the aniline. So only possibility is option C. So thank you students. Thank you for attending the class. My next class will be on 3rd exactly at 2 o'clock. If you are liking my class, kindly press the like button and also press the bell icon. Share these videos among your friends, relatives and neighbors, and do not miss my next YouTube session that will be exactly at 2 o'clock on 3rd. So take care students, keep studying and keep preparing for competitive level exam, and also inform your friends about the plus classes. Ask them to subscribe the plus classes, and whenever they join, let them make use of the code BHAVANILIVE. This will be the code they will be using. So bye bye and take care, and see you on 3rd exactly at 2 o'clock.